Hello everybody, I'm Mark Tewksbury, your host for this program. Our goal is to reveal the methods and materials that turn out the everyday products we see around us. If you think you know something about these items, you might be in for some surprises. There's a whole world of things waiting for us to discover here on How It's Made. On today's show, hearing aids, 3D puzzles, rubber mats, and toilets. You often hear people say that we should cut back on eating so much sugar, but then what would we do with it all? Believe it or not, we could add it to our irrigation systems to fight pollution. Sugar nourishes soil bacteria without forming greenhouse gas. Who knew? It's easy to take sound for granted until you lose it due to a serious hearing disorder. Thankfully, this tiny hearing aid brings back the music. Loss of hearing causes a serious handicap, but happily it can be remedied thanks to hearing aids. But before fabricating the aid, the degree of hearing loss must be precisely measured with this apparatus called an audiometer. So they make a mold of the ear canal. To protect the eardrum, an autoblock is inserted. Next step is to pour in a silicone impression-making material. It solidifies and is then removed from the ear. This congealed mass, representing the ear canal, is then soaked in warm wax to obtain a positive imprint. Then the silicone container is filled. The silicone hardens in only 10 minutes. The hardened silicone block is removed, and the excess of the imprint is removed so that only the essential part is retained. The imprint must slip easily into the ear. It's now the molding stage for the hearing aid. Acrylic is poured into the mold before placing it into this ultraviolet oven. Without emitting any heat, this oven hardens the acrylic. Here is the raw prosthesis without its electronic components. This plan details the electric circuit of the amplifier. Holes are pierced for the volume control. These components are tiny. Here's the volume control, the miniature microphone that captures sounds, and the earphone which functions as a speaker. This tiny braided wire of 7 conductors is soldered to the amplifier and the other parts of the prosthesis with pewter. The hybrid circuit is inserted into a silicone casing, which assures it protection. Then the wires are soldered to the speaker, and they verify the proper functioning of the volume control. A hearing aid must be very discreet. That's why they cut the excess with a diamond disc. They also remove the roughness with fine sandpaper. The holes we see here are used to vent air from the earphone. This silicone tube is used to make the vent. Acrylic is poured onto the tube to form a tunnel. Ultraviolet light is used to harden the acrylic. Afterwards, the tube is removed. This hole is used to position the fastener, a small wire which allows for removing the hearing aid from the ear. Then the battery is installed. Only a few parts, such as the microphone, remain to be put in place. Then everything is delicately assembled into the interior of the prosthesis. The 2 parts of the hearing aid are then glued together. Ultraviolet hardens the glue. The plate used to position the prosthesis components is cut away with a drill. Then the hearing aid is manually polished to make it perfectly smooth and comfortable. The prosthesis is now completed. There remains one important step, verifying its electroacoustic characteristic. It's with this analyzer that they validate that the hearing aid conforms to the original prescription. These minute prostheses allow us to solve the main hearing problems. Microfabrication of a single unit requires a little more than 2 days of work. Remember putting together these simple 60-piece kids puzzles? Well, now imagine doing a 1,500-piece puzzle, 3D, with the pieces going up, down, and even sideways. Now there's a challenge. Flat puzzles are well known by everyone, but 3D puzzles present a different challenge. These three-dimensional puzzles are first conceived with computer software. Good blades are needed to cut puzzle pieces. Here are the blades for the master die, which will cut out printed sheets of different models. This rubber will be used to eject the die. The master cutting die is unique to each puzzle. It is the specific pattern used to make the puzzle. They measure it meticulously to obtain a perfect register. It's imperative that the die not move during the cutting, otherwise the pieces would be cut at the wrong points, so they very firmly secure it in place. The carbon of the die is positioned. It's somewhat like printing the master. Alignment is again verified, a highly important step which assures the quality of the final product. Finally, they install this large metallic plate, which is the cutting base. It will be on this surface that the master die will strike. Once measurements are finished, the drawer of the die is slid into place. This press cuts the pattern seen on the puzzle. Here's how it works. The sheets, or printed cardboards, go into the drawer one by one, where they are cut according to the master model. We clearly see the press making the cut in the puzzle sheet. The cut sheets pile up on one another, and at this checkpoint, they verify the precision of the cut. They make sure that every piece is correctly shaped. Now they go to the foam support of the puzzle. This guillotine is used to cut the polyethylene sheets onto which they will glue the cut images. Foam sheets are inserted into this laminator, heated to 232 degrees centigrade. The sheet with the design on it is glued onto the foam with a thermosetting adhesive. Now they glue the printed sheet onto the foam sheet. Once the adhesion is finished, the puzzles are stacked on one another, and they proceed to the unbuckling operation. By pulling, they remove the surplus cuttings. The same design is printed several times on a sheet, so they must separate each puzzle. This step is called the reduction of the models. Now the pieces have to be separated. This decorticator handles this task and sends the pieces down a chute. Packing cartons arrive already made up, and the puzzle pieces are placed in their boxes. No less than 15,000 puzzles are produced here each day. Since it began operations, the company has created more than 300 different puzzle models, from quite simple ones to much more complex designs. The largest of them contain a total of 3,146 pieces. And you need real patience for this one. Ever wonder what happens to old used tires? Believe it or not, we now use them to manufacture rubber mats that can cover an entire arena. Now that's great recycling. Used tires are a real source of pollution. This pile represents about 100,000 of them. At any rate, these tires will have a second life. They'll be recycled to make rubber mats. Each day in this factory, they recycle 15,000 tires into mats. Tires have to be reduced to little granules, but first, this conveyor feeds the tires into the washer. Tires are washed with a water-based biodegradable preparation. Then they're sent to the shredder. The shredder has 2 rows of large teeth. These grind up the tires into pieces. This shredder is able to cut up almost 1,000 tires an hour. They come out as fairly good-sized pieces of tires, which are then shredded a second time. Metal is magnetically separated from the rubber, and the metal pieces are recycled at another factory. Other components of the tires, such as fiberglass and nylon, also have to be separated. They use a sifter to get out unwanted rubbish. Recuperated rubber particles purged of foreign materials measure about 2.5 millimeters. Some 16 tons of tire particles are piled up in this recycling depot. But the particles are still too large to be used. They're sent to a secondary shredder's supply tank, where they'll be reduced even further. This tractor feeds the secondary shredder. Grinding action produces a kind of rubber powder. The powder is spread out on these enormous molds. This mold has a length of 7 meters and a width of 1.2 meters. Thickness varies according to the product being made. The molds filled with rubber powder are stored in this loading magazine of the press. Once full, the molds are sent to the rubber mat press. Here's the mat press. The powder has to be cooked at a very high temperature for about 30 minutes. Cooking time depends on the product being made. The cooked mat goes through the unmolding unit before being sent off to cool. The rubber mats are still extremely hot. They're cooled with jets of water for a period of several minutes. The cooled mats can now be sent to the next department. This conveyor in the cutting center positions the mat before it's cut. The mat is vibrated to eliminate any surplus water. Each rubber mat is now cut up into 3 pieces. The cut mats are then stacked into a pile and stored before being shipped. The company also makes mud guards. These are fabricated the same way as the preceding mats. After having been cooled in water, but while they're still warm, they remove the surplus rubber. This operation is called notching. Hard rubber rings are also produced at this facility with the same fabrication methods and, as always, from old used tires. Over a 12-hour period, this facility makes no less than 12,000 rubber mats from old recycled tires. This translates into good news for our environment. This household item is something you might take for granted. But can you imagine life without it? The toilet, a shiny, sculpted marvel of manufacturing. The first public restrooms appeared in ancient Rome when the Emperor Vespasian built latrines. Such public urinals became widely known as Vespasiennes by 1840. In 1775, the invention of a water flush system created toilets somewhat resembling today's convenience. The valve and siphon were added in 1784 and the septic tank in 1896. A toilet is an everyday object whose fabrication requires several days of work. It involves assembling several molds, called tools. Each new product requires the design of a master plaster mold, from which they will produce a plastic tool. This latter will be used to create plaster duplicates used as production molds. The plaster production mold of a toilet is made from 6 different tools, which have to be assembled. Their lifespan is only 2 months. The process begins with a mixture of water and plaster according to a precise recipe. Then the liquid is poured into this filling hole of the tool. Once the plaster hardens, they can proceed with unmolding. They strike the end at the junction of the plaster mold and the tool with a rubber hammer so as not to damage the plaster. The pieces are gently assembled. The toilet softly takes its shape. It's in this same mold that they will later color the clay. Then they install tensioning straps. Little blocks are inserted between the mold and the strap to increase the tension. The mold will soon be filled with liquid, and they thus prevent any distortion. Here a new recipe is being prepared. This time it's a slurry, a composite of clay and silica. This preparation is spread out over 48 hours. Now they install the core, the upper part of the mold. They can now proceed with the filling. This copper distribution pipe, connected to the tank containing the slurry, permits the filling of several molds at a time. They need about 20 kilos of the mix per bowl mold. After an hour, the slurry has attained a thickness of 1 centimeter. The plug is pulled to allow the excess slurry to run out. They can now unmold the still fragile piece. This thicker slurry is used to adhere the 2 pieces together. They cut the holes and unmold the ensemble. The toilet is now molded. Then, to obtain a perfect appearance, they remove the little fillet formed by the surplus adhesive slurry. The toilets air dry for 36 hours, then in a warm air dryer for 12 hours. Finishing must be impeccable. They carefully sand the surface to make it perfectly smooth. A vacuum draws up the dust. Then with a jet of compressed air, dust and debris are blown away. Bowls are hand-painted in a special room. As for the water tanks, they're painted by an automated robot. This truck carries the different parts to the final fabrication stage, baking. The toilets remain in this oven at the very high temperature of 1,176 degrees centigrade for 23 hours. It takes this long to fuse the clay and silica. The paint then becomes hard and shiny, and it's all done. The toilets in the different bowls now take on shapes more elegant than in the past, but the fabrication of each one of them will have the same basic construction steps, involving 20 kilos of slurry and almost 4 days of labor. If a picture's worth 1,000 words, I hope what you saw today speaks for itself. Our goal was to take you behind the scenes to the world of manufacturing. I'm Mark Tewksbury. See you next time on How It's Made.